Hey everyone, let's just dive right into this. Welcome to your quick, super focused pre-test explainer. We are here today to help you absolutely crush that upcoming math test. I know, algebra can sometimes feel like this confusing jumble of letters and numbers, but I promise you, by the time we're done here, you are going to feel totally confident and ready to go. But before we jump straight into the numbers, I actually have a quick question for you. Have you ever wondered who actually invented all this algebra stuff? I mean, we tend to think of it as just arbitrary rules made up to torture us in school, right? But it's actually this ancient, highly logical, puzzle-solving system created by literally some of the brightest minds in human history. So here is our quick roadmap for today. We'll start with the ancient roots, then hit variables and constants, move on to the balancing act, figure out isolating the unknown, and finally wrap up with some actual practice problems. All right, section 1, ancient roots of algebra. Humans have been solving for unknowns for thousands of years. Think about that. Back in 1900 BC, Babylonians were writing out equations entirely in words. And then by 200 AD, ancient Chinese mathematicians were using physical counting rods to solve early math problems. Fast forward to the 9th century, and a Persian mathematician named Al-Khwarizmi wrote a book that gave us the actual word algebra, which comes from an Arabic term meaning reduction and balancing. So when you sit down for your test, you're actually participating in a thousands of years old tradition. Pretty cool, right? Moving right along to section 2, variables and constants. Okay, so here's your essential algebra vocabulary for the test. As we know, algebra uses letters to find unknown numbers, and an expression is really just a combination of terms, coefficients, variables, and constants. You definitely want to know these definitions cold for exam day. The really crucial point here is understanding the fundamental difference between the two main players. On one side, you've got variables. These are alphabetical letters like X or Y, representing unknown, changing numbers. They're kind of like hidden identities that we need to uncover. And then on the other side, we have constants. These are the rock-solid fixed values, like the number 10 or the number 3. They are constants because, well, they literally don't change. Which brings us perfectly to section 3, the balancing act. An algebraic equation can be thought of as a scale where the weights are balanced through numbers or constants on both sides of an equal sign. Seriously, I want you to picture an equation exactly like a physical, beautifully balanced scale. That equal sign, that's the center pivot point, keeping the left pan and the right pan perfectly level. And that brings us to the absolute golden rule of algebra. Whatever you do to one side, you must do to the other. Guys, think about it. If you add a heavy weight to one side of our scale, what happens? Boom, it tips over. Unless, of course, you add the exact same weight to the other side. And the same goes for taking weight away. You just have to treat both sides identically. So, moving terms across the equal sign is literally like shifting items between those scale pans to maintain perfect harmony. When we want to find out what our secret variable weighs, we carefully move our constant numbers around, shifting them between the pans with math operations, all while keeping that equal sign completely true and perfectly balanced. All right, section 4, isolating the unknown. Let's find that variable. I highly recommend memorizing these 3 logical steps. Step 1, identify the unknown variable. Find your X or your Y. Step 2, use inverse operations to move the constants. Basically, if a number is added to your variable, you subtract it. If it's multiplied, you divide it. You're just doing the exact opposite. And step 3, keep the scale completely balanced. The whole end goal here is getting that variable completely alone on one side of the scale. And here is a quick, friendly teacher tip for you to avoid common mistakes on the exam. First off, always apply your BODMAS order of operations, parentheses, exponents, multiply, divide, add, subtract. Second, remember to treat variables exactly like normal numbers. They follow the exact same rules. Third, if you ever multiply or divide an inequality by a negative number, make sure you flip the sign. But listen, the biggest mistake I see is when students do an operation on one side and totally forget the other. So always check your final balance by plugging your answer back into the original equation. Okay, section 5, practice problems. Let's prep for this test. Here's practice problem 1. Find y when y plus 15 equals 30. This is a classic, super simple addition equation. Our variable y is sitting right there on the left side of the scale, but it's being weighed down by an extra 15. So how do we get the variable y completely by itself? Well, we use that inverse operation we literally just talked about. To get y isolated, we need to do the opposite of adding 15, which is subtracting 15. So we take away 15 from the left pan. But remember our golden rule. We absolutely must take 15 away from the right hand too to keep our scale perfectly balanced. So the equation becomes y equals 30 minus 15. And boom, there is our beautifully isolated answer. 15. Y equals 15. We just proved that y was hiding the number 15 all along. See how satisfying that is? Let's see how this builds into something just a tiny bit more challenging. Practice problem 2 is a word problem. It says, if you double a child's age and add 4, the answer is 12. Written out as an equation, that is 2x plus 4 equals 12. Let's tackle this two-step equation together, representing the child's mystery age with our variable x. So, we have to peel away the layers here, starting from the outside. Step 1, we get rid of that plus 4 by using the inverse operation, subtracting 4 from both sides. Our scale balances out to 2x equals 8. Okay, step 2, x is currently being multiplied by 2. Well, the inverse of multiplication is division, so we divide both sides of our scale by 2. And brilliantly, we discovered the answer is 4. The child is exactly 4 years old. And you know what? If you plug 4 back into the original equation, double it to get 8, add 4 to get 12, it balances perfectly. Great job on that one. All right, for our final review question today, let's look at a division problem where things are fractioned out. If x divided by 7 equals 21, then find x. Here, our variable x has basically been sliced into 7 pieces. To build x back up to a whole, we need to do the exact opposite of division. We use the inverse operation, which is multiplication. If we multiply the left side by 7, those 7s cancel out, and x is completely free. But, of course, we've got to multiply the right side of our scale by 7 as well, so we end up with 21 times 7. And doing that quick math, we get 147. Now you see how easily you can use inverse operations and balancing rules to uncover any hidden variables. But remember, algebra isn't just about passing your test. It's the exact same balancing logic that engineers use to build bridges and scientists use to launch rockets into space. It's a real game changer. So what real-world mysteries will you unlock with it? Good luck on your exam, you're going to do great, and we'll see you next time on The Explainer.